All right, so normally we will be live streaming this on YouTube. Unfortunately, the stream is not working today, nor is my mirror on my monitor. So some first day hiccups here, but I will be recording this if you want to refer to it. And if anybody didn't show up on the first day, well, hopefully they'll get a recording if it works. In any case, my name is Dr. Chris Burke. I will be your instructor. This is Computer Science 2, CSCE 156. Today we're going to give a course overview, we'll talk about the syllabus, and then we'll of course get started immediately on Java and a Java environment. And once again, I'm not able to see this behind me, so bear with me as I look back with you. So again, we're going to give a course overview. We'll talk about the course schedule. It's up and running. Everything is in the can up on Canvas right now. We'll talk about labs and assignments. That's how you're going to be graded for this course. The assignments actually are a semester-long project. It has, I think, 6 phases. There's a design document that goes with it where you will be detailing your design before each one of those phases so that we can give you feedback on it. It is a collaborative endeavor, so if you want to team up with somebody, a partnership, a pair, then that's perfectly fine. If you want to work alone, that's fine, but groups of 3 and above are not allowed. And then we'll, of course, talk about the resources that are available to help you with this project. And then, of course, the course resources in general. This is the only time I will be using PowerPoint, by the way. We'll be doing everything, notes and markdown and stuff like that. Overall, at the end of Computer Science 1, let me go ahead and increase this. Is it good enough for everybody in the back there? Yeah, okay, good. All right, let's get rid of that. At the end of CS1, you should be able to approach a reasonably complex problem, design a top-down solution, and code a program in a high-level programming language. For many of you, that's going to be C, coming from 155E. For the other half of you, that's probably going to be Python, coming from 155A. And then if you've got some experience in other languages, that's fine too. If you don't have any experience in Java, that's fine. The first 3 weeks, we're going to cover that. The key realizations, however, that you should come out of the CS1 course are that computers and programs are not problem solvers. It is still the person. It is still the person behind the machine that is actually solving the problem. Computers are dumb and they do exactly what you tell them to do, even if you tell them to do it wrong, right? Programs are only good at automating solutions. Computers are good at lots of data processing very, very quickly. Humans are not good at that. But computers are still not good at problem solving, actual problem solving. So by the time that you, here's a quote, I believe that this is Douglas Adams. By the time that you've sorted out a complicated idea into little steps that even a stupid machine can deal with, you've certainly learned about it, something about it yourself. Right? That's at the conclusion of a CS1 course. The overall goal of Computer Science 2 is to approach a problem from a fundamentally different approach, a bottom-up approach. First, at the end of CS2, you should be asking yourself, when you approach a problem, design questions first. What are the entities or objects that would be appropriate to model this problem? Right? How would these objects interact with each other to solve the problem? And what data structures or algorithms could I pull off the shelf to make this problem, this solution efficient? Right? And again, it's a fundamentally different approach. It's a bottom-up approach. You're doing the building blocks first, rather than a top-down solution where you're taking the problem and you're breaking it up into smaller and smaller chunks. You are starting with those chunks as building blocks to solve the problem. And another quote here from Eric S. Raymond, I believe, is that smart data structures and dumb code are a lot better than the other way around. Right? You might have written some very, very clever code in CS1 to get the job done. You're going to not write clever code. You're going to write dumb code and use smart data structures this time around. Right? So here's our approximate schedule. The first 3 weeks, as I said, we're going to be covering Java. And in the H section, we'll be covering Python as a third programming language. Then we'll continue with Java, but in the context of object-oriented programming. So we'll talk about Java basics, but not necessarily objects, and then we'll transition into objects and OOP, object-oriented programming, including the 4 pillars. That's encapsulation, abstraction, polymorphism, and inheritance. Then we'll transition into another programming language, SQL, Structured Query Language, because we'll be using it in database and database designs. So we'll spend about a week, 3 weeks on that, because we'll be going through how to design a database, how to implement a database, how to query out of a database. And then we're going to merge those two things together. Because normally, I mean, you're not sitting there typing and querying a database. I mean, if you're running a manual report, you are. But ultimately, you're going to be writing code to connect to a database. So we'll take your Java code and your database code, and we'll merge them together so that they're working together in tandem. That your Java code is pulling data from your database and persisting, saving data to your database. Then about 2/3 of the way through the course, we'll transition yet again into data structures and algorithms. We'll look at list data structures, algorithms and algorithm analysis, including Big O analysis, searching and sorting, which you might have already seen in CS1, but we'll now revisit it in the context of algorithm analysis. Stacks, queues, and finally binary search trees and heaps will round out the course. So there's our 15 weeks going forward. All right. Labs are going to be weekly labs. There are 15 of them. Right? It constitutes about 20% of your grade if you look at the if you look at the point distribution. All of them give you starter code that it's provided on GitHub. This week's lab will walk you through that process. You're going to get set up on Eclipse. You're going to clone a project. You're going to create your own project, but then clone another project. You're going to do a basic Hello World program, and then you're going to hand it in, look and see what that hand-in process looks like. Attendance is required. In other words, attendance is graded. That's 5 points. So your lab itself is 20 points. It's based on completion. And then whether or not you attend your lab, that's another 5 points. We'll talk about how to earn those 5 points here in a second. We have learning assistants. We have about a dozen learning assistants there to help you during lab, ask questions. You can ask questions about your homework if your lab is done, etc. It can be completed asynchronously. So if you want to do it before, that's fine. If you don't want to go to your lab, that's fine. Don't get those 5 points and you complete it and you're done, right? It's based on completion. You'll have these what are called JUnit tests that you if you just hit this button, we'll show you how to do it. You hit this button and it passes all your tests. If you have like 5 tests and 5 out of 5 pass, there's your 20 points right there. You earn full credit. Hand it in, make sure that it works on the grader. If you've got 4, one of them is failing and then 4 of them are passing, that's not 80%, right? That's still a 0. You need to go back and you need to fix whatever is wrong with it, get all 5 of those tests running. That's going to be your 20 points there, right? So 20 points or 0 points. The attendance points, however, can be earned back. If you choose not to go to a lab, that's your choice, right? You won't earn those 5 points initially, but if you complete the lab and get your 20 out of 20, we'll go back and give you retroactively those 5 points. Right? So I've used this policy in CS1 for several years, and it's worked out. Generally, people will choose to attend the lab regardless of whether or not they're anticipating to get those points back. About 60 to 70% do. I would highly encourage you to attend all of your lab sessions at least for the first few weeks. Right? Once you get into the groove, then you can decide for yourself, I don't really need to go to lab, I can do it on my own. Right? But make sure that you're attending those initial first weeks. Okay? Assignments constitute the rest of your grade, about 80%. Right? There are 8 assignments total. We start counting them at 0 because, like any self-respecting computer scientist, we start counting at 0 because of indexing. So your first assignment is 0.0. It's 3 basic programs in Java. Some of these programs I've taken from past CS1 courses. It's individual, no partners is allowed, and no collaboration is allowed on that first one. That first one, you need to understand whether or not you're ready for this course, right? Did you do well in CS1? Everybody got a good grade, but did you actually learn, right? Are you able to do this assignment in the language that you did in CS1? Are you able to do that assignment in C, or are you able to do that assignment in Python? If not, you might not be as well prepared for this course as you think. Right? And that's why we require individuals for the first assignment, right? So that you're not relying on a partner. After that, assignments 1 through 7 are all project phases. You start out doing some basic object or design and EDI, that's electronic data interchange. So you'll be reading from a bunch of CSV files and saving them to a bunch of XML or JSON files. Then you'll have an application design and implementation, including some testing. Then we'll move on to database design, database loading, database persistence, and then you'll implement a sorted list class and integrate that into your project as part of the data structures and algorithms part of this course. Included in this is a design document. So prior to each one of these phases, you will be writing and maintaining a design document that you'll be handing in. We'll talk about this. In fact, I bring in some folks from the Writing Center to help me talk about how to do technical writing. You're not writing a 5-paragraph essay. You're not writing a poem. You are writing a design document that describes the design of your system, right? And then we're going to give you feedback on that. Well, no, that design's not going to work because of this reason, this reason, and this reason. Or that looks good, but what are you going to do in this case, right? We're going to give you that feedback, and we're going to try to give you that feedback 1 week before the actual assignment is due, right? Because you've given us that design document early. And then you're going to be able to go back and fix your design if there was a faulty design. Again, each phase is graded based on correctness and design. In each one of the handouts, we have a full rubric with a full point distribution. Right? And again, that living document, that design document, will be due 1 week prior to each assignment. Each draft is based on completion. You turn in that draft and you put a full effort into it, then we're going to give you your full points for that draft. We are only going to grade based on content on the final draft that we see at the end of the semester. You're going to be updating this throughout the semester. We're going to give you feedback. Nope, that's terrible. That sucks. You haven't done enough, right? Or you haven't addressed this issue or that issue or that issue. Fine. In the next draft, you will address those issues. And by the end of the semester, you should have a perfect design document because you've gone through 6 or 7 drafts of this thing. You are expected to follow the IEEE template that we provide. We provide a Word file and LaTeX. If you know LaTeX, great. If you want to learn LaTeX, good luck. If you don't know LaTeX and you don't want to learn it, that's fine. You can go ahead and use the Word document. Right? Again, we only grade based on the final one. Right? Collaboration is highly encouraged on the project and on labs, by the way. Right? You may discuss at a high level with other teams, but all work must be original. So within your team, of course, I would expect you to have the same code because you've both written it and you've both collaborated on it. And that's going to be shared equal work. So don't just say, you take the even ones and I'll take the odd ones, or you take that part of the system and I'll take this part of the system. You need to actually collaborate together on everything. You need to whiteboard stuff and bounce ideas off of each other. It's really, really helpful to have that second pair of eyes because at some point you're going to get stuck and you're not going to see something really, really obvious. If you bring in a second pair of eyes that sees something from a different perspective, that thing that was not obvious to you becomes obvious to somebody else, and you solve it much more quickly. Right? So we highly encourage this kind of collaboration in pairs, of course. Right? You also get to develop your soft skills, right? Your communication skills with each other, your teamwork skills, your conflict resolution, right? So if one partner is not pulling their weight or not showing up to the designated meetings that you've decided upon or something, then you have an opportunity to resolve that conflict and say, look, I need you to start doing this, this, and this for this partnership to continue. If not, then I'm going to have to dissolve the partnership and find a new partner or start working alone, right? So it's an opportunity to develop one of those really, really essential soft skills that are going to be important throughout your careers. Again, partners can mooch. Be careful. They can disappear. They can flake out. They can drop the course. Right? Choosing to work in pairs means that you are taking responsibility for both of you. Right? Each one of you is taking the responsibility for both of you. And that's where that conflict resolution comes in. When that doesn't happen, then that's when you need to develop those skills and say, no, I'm out of here, right? Do not undermine the learning process of your partner. Don't be the moocher, right? Don't allow the other person to be a moocher. Make sure that you are both putting in a full effort and full equal effort. And of course, use GET. I mean, I used to have to say that. Hopefully I don't have to say that anymore. It's 2026. and everybody should be using Git. If you do not know how to use Git with respect to Eclipse, which is our preferred IDE, that's fine. I've got a video walkthrough 0.2 or something like that I would point you to on how to use Eclipse or use Git in Eclipse. Right? And then finally, the use of AI tools is prohibited for this course. For design, now there are some instances in which we do allow you to use AI. For example, the generation of mock data, right? But there are websites to do that, mockaroo.com or something like that. But to actually generate code, to generate your text for your design document, to generate your design, it's prohibited with respect to those uses. All right? You don't really learn anything when you're letting AI do everything for you. All right, so take the long view here, right? We've got 15 weeks. You need to look at the long, it's actually the near term with respect to the semester, but the long term with respect to the semester, let's say. Make sure that you understand where you're going. Make sure to read ahead on what the expectations are. For example, the best way that you can organize yourself is through something called, say, a Gantt chart. Now, we've provided this free to you. What it is it's a project management tool that I believe is over 100 years old. You have a certain due by date, right? And you have certain tasks that need to happen before that due date. For example, you have to do phase 1 before you do phase 2. You have to do phase 2 before you do phase 3, et cetera, et cetera. So when you look at a due date, what you do is you work backwards. All right, that part is going to take me 2 days. That part is going to take me 3 days. That part is only going to take me 1 day, right? And then you organize it so that you know what you should be doing throughout the process. That you're not waiting until the first assignment, for example, is due in week 3. That you're not waiting to Friday of week 3 to get started, right? Instead, you should be getting started right now. There's today, right? And in fact, it's highlighted with that red column right there if you can't see the color. What should you be doing today through Wednesday, right? Well, I should be reading the handout and getting an idea and outlining an idea for how to approach each one of those problems. We also have labs here. Your lab is on Wednesday, so what should you be doing on Wednesday? You should be doing your lab. Once you've done these things, for example, if I went home today and I read through the entire first assignment 0.0, I'd say I'm 100% done on that, right? And then it starts to gray out. Right? Or maybe I didn't read all the way through it. I only got read through the first 2 problems. Well, okay, I'll give myself a 50% on that, right? And you'll see as this gray goes along, that means that it's done. The blue or purple, I guess it is, that's the things I still have to do. It designates what today is. This gives you an idea, am I behind or am I working ahead, right? This is an excellent project management tool that has been used in industry for over 100 years, right? If you want to use it, great. If you have a different way of organizing yourself, fine, right? If you don't want to use it and you just want to go ahead and roll the dice, that's fine too, right? But there are consequences to each one of those decisions. Right? This is not something that you're going to hand in. This is a tool that we've provided, right? So each one of you can download your own copy, put your names on it if you want, but you're never actually going to hand it in. We don't care about it, right? But we will, however, follow along. Right? So for example, over here in CampusWire, what I've done is I've put up a pinned message or a pinned post, I guess, of the progress of a reminder of what you should be doing. And just as I said, you should have read through the handout to understand the assignment. Think about how you would approach and solve each problem and the programming language that you are already familiar with, right? You don't have to actually, program it in C, program it in Python. You can just say, well, here's how I would do it. Here's my outline of that program. And then eventually you're going to program it in Java. Right? What should you be doing by the end of the week? You should have set up your Eclipse environment. You'll be doing that on Wednesday. Maybe set up all the files necessary for like all of your source files, although not having written them yet. And then maybe have an outline for each one of your programs. That tells me that I am on task, right? That I'm not falling behind. And then we've got next week. What we've done is we've outlined the first 4 assignments, I think. Yeah, first 4 or 5 assignments here. By then, we didn't do the last ones because by then you know how you work, right? It doesn't take me 3 days to read the handout. Right? I'm going to go ahead and take that and change that to I don't know, one day or something like that. You can change the dates in here. It's your copy. Do whatever with it that you want, right? That is an excellent way for organizing yourself for this course. If you have an alternative, if you do to-dos on like tasks on Google or something like that instead, that's fine. We don't care, right? Organize yourself. Take the long view, though, right? Start early, right? Pace yourself. And in industry, there's something called a burn down chart, right? Where you've got this much work to do for the next 4 weeks. You'd like to see a nice linear burn down where you're working at a constant rate. If you have a burn down that is like this, where you haven't done anything, you haven't done anything, you haven't done anything, in other words, you've procrastinated, and then finally on the last day you want a burn down that goes down immediately, that's never going to be successful, right? So make sure that you're pacing yourself, that you're working at a sustainable rate, not waiting to the last minute and getting everything done, not front loading yourself and trying to get everything done on the first day. We haven't even covered Java yet, so that's not reasonable either, right? I guess if you know Java, you can go ahead and push right on through, right? Have a good, well thought out design on paper, in other words, your design document, before you even start coding, right? If you do not have that, then you're going to go down one road that it leads to a dead end, right? And you're going to try to persist and push through that dead end, no matter how much, no matter how ill-advised that is. You need to back up and go a different direction sometimes, right? So sometimes you need to throw something away and start over, right? Design your test cases before coding. This used to be a suggestion. It is now a requirement. Last year, it was pretty successful. Last year, we started requiring formal JUnit tests at various stages in your project. And so you'll be required to do that now, that you're going to be designing your test cases before you design your code. That's TDD, test-driven development, right? Use proper debugging techniques, right? If you don't know how to use a debugger, I'll show you eventually when we've got some more substantial code to work with. I'll show you how to use it in Eclipse. Those coming from 155E probably have formal exposure to like GDB. Those coming from 155A with Python, I'm sure that there's some sort of built-in, if you use PyCharm, yes, no? Or what did you use? What IDE did you use? Command prompt. Okay. I have no idea what a CLI for Python would be for debugging. But anyway, again, take this theme of this course here to heart. That smart data structures and dumb code are a lot better than the other way around. You're going to want to write dumb code. By the end of the semester, we'll see a data structure that exemplifies this. You can have really, really complex code in like quicksort or merge sort or timsort or something like that. But I'm going to show you code that you put stuff into this data structure and you take it out and it's efficiently sorted already. Doesn't get any more dumb than that. Put stuff in, take stuff out, right? So always be looking for those shortcuts, not the shortcuts as in I'm going to cheat or I'm going to use AI or something like that. Look for shortcuts as in smart data structures that you can use to make your life easier. Right? Also keep in mind about technical debt. If you don't have time to do it right the first time, then you'll have to find time to do it over. Right? If you don't have a good design in phase one, then you're going to be fighting that design. You're going to be fighting those bugs that you have in phase two. If you don't go back and fix them, you'll be fighting those design issues and those bugs in phase three, right? So make sure that you're staying on top of stuff and that you are not technical debt is basically a loan on your future self, a loan on time. I'm going to go ahead and try to get it done quickly, right? Well, now there are issues and bugs that you're going to have to fix later on. In other words, you've taken out a loan that you're going to pay interest on in the future. It's going to take you twice as much time in the future to address those issues if you just had a better design up front, right? Then you wouldn't have had those issues. Make sure that you're asking questions and taking full advantage of help hours. Like I said, we have 12 learning assistants throughout for the whole semester. They hold help hours 2 to 3 each, so that's about 50 help hours throughout the entire week. That's not including your labs and your hacks, your lab times. I'm thinking CS1 here. Right? Attend help hours and get started early. Get feedback early if you need to. Right? Ask an LA for feedback on your design if you need to. Otherwise, that's where the design document comes in. Right? So let's just go ahead and take a look at Canvas over here. Nope, that's not it. It's over here. So if you take a look at Canvas, you can see that it's all laid out already. Everything, the entire schedule here is all set. First of all, where can you get help? Well, it's right at the top, getting help, right? And instructor help, and instructor info. At the very top, we've got a full grid. It's not complete yet. Some LAs are still deciding their help hours, but there's the help hour grid. You can see that pretty much almost every hour throughout the week, at least, eventually, we will be filled with a help hour here or there. There I am. I'm holding my help hours on Mondays and Wednesdays. You can find me on that grid. Maybe they didn't put me on that grid. I should be on there. But otherwise, we've got course leaders. We've got learning assistants. You can read all about them and meet them in your labs and in your help hours. Let's come back over here. You can learn more about the Learning Assistant program, and I would highly encourage you that at the end of this course, if you've done well in CS1 and CS2 and you want to be a part of that program, then you should apply for it next year. Right? There's an FAQ, frequently asked questions for the course, course information, and some other resources here that you can take a look at. For example, free textbooks. There's the syllabus. There's a Git tutorial. There's the hand-in that you'll be handing in all your code. There's the web grader that you'll be grading all of your code. There is, in fact, a textbook. It's not official for this course because it's free. It's my textbook. I just wrote it several years ago. It covers most of the topics except for object-oriented programming. So that's also a free resource there. Make sure that you go through the syllabus, which we will here in a second, and a bunch of other sources. For example, an anonymous feedback form to the department. If you're having problems with me or with anybody else in the department, you can always contact our chair, our school chair, and talk about it, right? Anonymously or identified if you need to. Some other textbooks that cover Java, data structures and algorithms, SQL, and other Java resources are down here as well. So plenty of free stuff. That's why we don't have a textbook at the bookstore for you to buy, or at least torrent once you know which textbook it is. Right? Hint, hint. Right? With your other classes, that is. All right, so what else we got here each week? We've got the dates. We've got what we're covering tentatively for each one of those lectures. You'll note here that when I'm done, I will come back and fill that in with a link to the live stream or the recording of that lecture. There's your lab for each week. It's linked, right? There's lab 1. And in fact, we have a full walkthrough on lab 1, video 0.3 or something. I forget what it is, but it's posted on CampusWire. There's the syllabus. There's the Gantt chart just behind me that you can get your own copy of. And then there's the getting started videos 0 through 1 through 03, right? I think at this point, you only need to watch the one for lab 1 walkthrough or just do the lab 1 by yourself. And then finally, what's due in each one of those weeks. You can see here that assignment 0 is not due until Friday of the 3rd week, right? And there's also something that you should know about next week. There's this PDC knowledge exam. I put exams in quotes there because you are not graded based on your answers. You are graded based on completion. So you go through, answer the questions as best as you can, and as long as you answer all 30 questions, it's all in Canvas. It's not proctored or anything like that. Don't cheat by looking up the answers. We want an actual measure of your knowledge of PDC. That's parallel undistributed computing. But just go ahead and get that done at some point in the next few weeks. Then we've got object-oriented programming. We've got SQL. Right? Each one of these is mapped out. Right? So all the way to the end of the semester, right? Where we've got some padding down here if we need it. Right? Any questions so far? No? All right. Let's come back over here. CampusWire. You all should have received and hopefully accepted already an invite to our online forum. I will be making regular posts, announcements. This will be our de facto communication tool. I will not be using Canvas unless it's absolutely necessary. Instead, announcements and other important information will be posted here on CampusWire. It allows you to ask questions anonymously, privately, or publicly. Right? It allows students to answer other questions. For example, if somebody says, when is assignment 0 due? Right? Then we can have anybody can go in and say it's due on whatever date. Right? You can answer questions of other students. Again, you can post anonymously. So if you feel shy about asking a question, or you feel this is a dumb question, right? You can go ahead and post anonymously. If you post anonymously and ask us a question that require it's not working for like the web grader is giving me this, we're not going to be able to look at it any further than that, right? Because you're anonymous. So if you want to, you can do it privately, which is just to me and the learning assistants. In any case, this is an excellent way to communicate with other students, with your instructor, et cetera, because if you ask me a question via email, I'm going to say that's a great question, but probably 50 other students have that exact same question. So let's take that over to CampusWire. I'll answer it once so that everybody gets the benefit of that answer. Right? So preferably, please go to, you can always email me if it's really, really sensitive and private, but please go ahead and use CampusWire as your main communication forum. Right? Canvas is just the front-facing stuff. All those links will actually go to GitHub, and everything is actually hosted on GitHub. You don't need to go to GitHub directly unless you need to go and get actual files, which you will later on. Like I said, there is a free textbook here. It covers everything except for object-oriented programming, and it's free. I wrote it. Right? Pull requests are welcome if you find a typo or something in there. And then finally, YouTube. Let's go back over to Canvas here. You'll see that for most topics, for example, when we get into Java later today, right? I've got a 13 video series here that gives you another perspective on an introduction to Java, right? It's not just going to be the lecture. It's going to be the same structure as the lecture that I'm going to do, but it's going to be different examples, a different perspective, et cetera. So you can go ahead and start watching those videos in parallel or move ahead or as reinforcement for what we do in lecture, right? So I do have some videos based on that. I don't have any videos based on object-oriented programming, unfortunately, but I do say on databases, on list-based data structures, algorithms, algorithm analysis, et cetera, et cetera. So that is yet another resource that you have pre-prepared lecture and tutorial videos on YouTube. We've already looked at the schedule. We've looked at the help hours. We've discussed the labs. Let's go ahead and take a look at the syllabus here. We won't. A lot of it I've already gone over, and it's kind of bad with dark mode up there, but more difficult to see on a projector. But there's the theme of the course that smart data structures and dumb code are a lot better than the other way around. This is a 4-credit-hour course because your lab is expanded into 2 hours. But also you need to understand what the prerequisites to this course are, or post-requisites to this course are. If you are a computer science major or computer engineering, software engineering, data science, whatever it is, and you need to go on to CS3, which is CST 310, then you need at least a C or better to move on. So make sure that you should be shooting for an A, right? It is, most people get A's, I'll say that, right? All they have to do is they just stay on top of your work, right? But you need at least a C to move on. Right? Again, what are the objectives of this course? Let me go ahead and zoom in a little bit. All right. By the end of this course, you should be able to pick up and learn a new programming language on your own, because this will be at least 2, or if you count SQL, 3 programming languages that you know by the end of this course. You should be able to pick up a 4th programming language on your own very, very easily. C# and go off and do Unity game programming, or what is Godot written in? Is it G? Is it what?
It's like its own thing.
Is it? Okay. And what am I thinking? Go, like Google's Go or whatever. Whatever. JavaScript is another example. JavaScript for web development stuff and all that crap, right? You should be able to recognize, use, and appreciate programs with an object-oriented flavor, right? Because we will have covered object-oriented programming. You should be able to design a database-backed application from scratch given a general problem statement. Sometimes people designate themselves as full stack engineers. They're not engineers, but they might have full stack stuff where you're doing stuff at the data level, the middle tier level, and then the presentation level, where somebody's doing all of those things. You're going to get a flavor for all of that in this course. Less so on the presentation layer. Instead, it's going to be all command line stuff. You should be able to understand and implement basic data structures, as well as recognize how and when to leverage appropriate data structures. The difference between a computer scientist or computer engineer, data scientist, whatever, and a mere boot camper is somebody that will immediately see, oh, I can use binary search on that to make it exponentially faster. Or if I take that approach, it's going to be order n squared, which with this data is going to take me 50 years to complete, right? I didn't put any keys on that database table, and now it's going to take forever to actually query something, right? Being able to recognize the situation in which that occurs and the solution to that situation, that's the difference, right? And you'll have that knowledge by the end of this course, hopefully. And then you'll be able to identify and analyze basic algorithms. You'll be doing more of that in CS3, of course. All right, we already gone through that. Those are the tentative topics that map back to those learning objectives. Continuation of instruction, I'll just let you know, right? I don't foresee, it's been a very mild winter already. We're going to have 60 degrees tomorrow or something, right? It's going to be awesome, right? There's the assessment, there's the assignments, labs, the PDC quiz, and free starter points, right? That used to be so that it rounded out to a whole number, a nice convenient number, and I just kept it because there's your motivation right there. You've got 100% in this course right now. Keep it up, right? They're just free points, okay? There's the standard scale. Lab attendance, again, if you choose to attend, you'll get that 5 points. If you choose not to attend, or I'm going somewhere that week, or I'm just way too busy, I can't make that lab session, fine. Make sure that you get your lab work done before or after, or by the due date. Oh, by the way, Cinderella due dates on everything. That means midnight due dates. So on that Wednesday, you have until midnight for your labs. On those Fridays when something is due, you have until midnight, or 1 second before midnight, right? But all of those are called Cinderella due dates, right? So make sure that you're, but again, make sure that you're attending for the first few weeks just to get the groove of the course. Assignments, we do not accept late work, so make sure that you're getting that in on time. 15th week policy, we do have stuff due during dead week, and so it's in writing now that it is due during dead week, including a lab and your last 2 assignments. Make sure that you're talking to the grader first to get anything resolved, and then come talk to me if you can't get it resolved. And then finally, no late work. Make sure that it works on the web grader. Works on my machine is not an excuse. Right? That means that your configuration is different than what we said that it should be. Right? That means that some mysterious reason it works on your machine, but it doesn't work on the grader. It's got to work on the grader. So turn it in. You can grade as many times as you want, by the way. You can turn it in, grade, use the grader, see if it works. Great, you're good. Oh no, it doesn't work. Go back and fix it. You can hand it in and regrade it as many times as you want up until that due date. Okay. Again, academic integrity, make sure that you're not collaborating in the ways that are not allowed. The use of AI, again, is prohibited. We'll skip that. And then just everything else that we've gone over, other resources that you have, including the Writing Center. They'll come in week 5 and talk to you about the resources that they provide, etc. So, any questions? No? What else do I have? All right, we already talked about the Gantt chart. So you know what? Let's just go ahead and get started. So if you haven't already, make sure that you are downloading and installing Eclipse. By the way, if you have a preference for a different IDE, you wanted to go with JetBrains or IntelliJ or BlueJ, fine, that's fine. But you're going to have to come up with your own instructions for building your project, right? I do have instructions that are up to date as of 2 years ago for IntelliJ. If you want them, contact me and I can send them to you. But otherwise, Eclipse is free. Its market share has dwindled in recent years, but I think it's still strong at about 30%. IntelliJ is larger, 30, 40%, maybe 50% by now. but also it's not free. It is free for students, so if you want to go ahead and use it, go ahead. But when you get out into the real world, I think you end up paying like $100 a month for it or something. So we're going to use the free stuff. Right? Once you, and by the way, it also requires that you install Java, the JDK, that's the Java Developer Kit. That is the compiler and all the code required to actually build stuff in Java, not the Java virtual machine. That's the Java virtual machine is something completely different that you probably already have installed on your computer. But the instructions for doing that are in Lab 1. Once you've done that, or in Lab 1, once you've done that, you can fire up Eclipse and it looks something like this. You can go ahead and create a new, and I can barely see anything. New, sorry, there we go. Let's go with Java project here. And you're going to have to give it a name. I'm going to go ahead and give it a name of CSCE 156 Spring 6, excuse me. Right? And that's going to be our project that I'm going to be using for demo code throughout the semester. You can go ahead and choose your Java here. Right? If you installed a more recent version, fine. I've gone ahead and gone with Java 21 here. I don't remember. I could have them upgrade on the Neuros, that is the hand-in system, to something, but if you want, if you need to, you can go ahead and downgrade, right? 21 is probably good enough, though. That's what I'm using, so if you're using 21, that's safe. And then here. By default, this thing might be enabled, this create info, module info. You want it to be disabled, right? So next, you can go ahead and go next. Otherwise, you can just finish the, I mean, if you're going to do really, really niche stuff or advanced stuff, go ahead and move on, but otherwise, this is good enough for us. Once you've got this, you've got a new project over here. There's the JRE, that's the Java runtime environment, and it's set to Java 21, version 21. And then you have SRC. What do you think SRC is short for? Source. That's where you start putting your source files. Now, in Java, you organize everything into folders. We call those packages. So what I'm going to do is I'm going to create a new package first. For example, if I wanted to create a package called unl.soc, right? unl.soc, UNL for University of Nebraska-Lincoln. Under that, we have the School of Computing. It's kind of an organizational, hierarchical structure, right? Let me go ahead and show you what happens when you do this. So let's finish this. There's a package, but it's empty. I'm going to go ahead and, let's see, where's properties? I'm going to go ahead and open where that is on my computer, okay? And let me go and bring this over here, and you'll see that a package is nothing more than a sort. In SRC, there's a folder, a directory called SRC. Within that, you have UNL. Within that, you have SOC, right? So you can organize things in folders and subfolders and subfolders and subfolders, however many times you want to go through, using packages like this. The IDE makes that completely opaque. We never see that stuff unless you actually want to, right? And in which case you'd have to sometimes you want to get access to those files because you have to turn them in. So if you're going to drag and drop, of course you need to get here. And remember how we do that? Right-click the project, properties, and then what it was, oops, nope, cancel that, sorry. Not that, but the project, right-click, properties, and then there's this button right here that will take you and it'll open it up the actual folder directly. Right? And then if we actually had anything in there, then we could go ahead and drag and drop it and hand it in. What is that bin right there? What do you think bin is short for? Binary, right? The source files will be compiled automatically by the IDE and placed into this bin folder. Right? We'll see that here in a second. Let's go ahead and create our first program. What's the first program in any language that if you do a new language, what's the very first program you always do? Hello world, exactly. And so I'm going to go ahead and create a new, where's class? There we go, class. New class, and I'll call this hello world. Naming conventions is kind of small to see, but you always go with upper camel casing. So if you've got multiple words, hello world, the first letter of each word is capitalized, everything else is lowercase, right? That's the convention. If you do something else weird like hello world, you'll see a warning at the top there that says you probably shouldn't be doing this, right? So hello world. I think I spelled it correctly. I can't see, right? But there we go. Kind of small, so let's increase. There we go. And at the top, you'll see, because I put it in that package, it's in unl.soc. What if I did a different package in the source file? That's a compiler error. Save that, save it automatically. And it's going to complain because you're in the wrong folder and you've designated this to be in a different folder. All right, so let's undo that and fix it. If you, you can always, drag and drop it to another package if you want to make it, to fix it or whatever, or change this package declaration up here or whatever. But you need to get it to actually compile. If it doesn't compile for any reason, you'll see a red mark here. You can hover over it and it'll tell you what's wrong and ways to fix it, just like any IDE would. Right? That is not AI. Right? Okay. First thing you need to do with any program is documentation. Right? What did I just do there? I did doc style comments. Right? So /**, and then I just hit enter, and it filled in the rest for me. As I type, this is a basic hello world program, right? Then it will continue that vertical line of stars. It's in a nice little blue formatting as well. Every non-trivial program needs to be documented. That's going to be part of your rubric. For now, we just need documentation on the class. Author documentation, describing what the program is, along with name or names, and maybe a date, right? 2026 now, 01/12, right? In the proper ISO 8601 format, right? We'll talk about that later. Otherwise, here's our class. Now, what does it do? It doesn't do anything because there's no code in it yet. What I need is a starting point. Now, if in C, this would be a main function. In Python, well, you can write a main function if you want in Python. Otherwise, Python just starts, if you run a script in Python, it just starts at the top and just keeps going, right? So in this case, though, we need an actual function as a starter. Public static void main string args. Those coming from a C background. By the way, you can close stuff. We're not going to need an outline. We're not going to need a task list. Go ahead and get rid of those. You can restore those. I'll show you how to do that later. You can take stuff and you can take these tabs and you can move them around if you want to. I can move it down here. I'm not going to do that. But you can organize your workspace however you want, right? And I'll show you how to restore it if you screw up and you accidentally close something. For example, this. That's not necessary, but like my console here, right? I can, if I close that, right? I lost that because what if I run this program, right? Yes. There's no output because there's no console anymore. How do I restore that? I'll show that to you here in a second. But we actually need code here to actually do something. So system.out.println hello world. There we go. A couple exclamation points there. Sorry. Semicolon. There we go. Now, if I run this, hopefully the console comes back automatically, and it does. I'll show you how to restore it manually later on. But there's our first program. Right? Some things that look familiar here, whether or not you're coming from a C background or a Python background. If you're coming from a C background, hopefully this looks familiar. Main, right? You can do that in Python too. Did you ever do that in Python? You created a main. Like if it's not defined, then you define main, right? And then that becomes your main entry point, right? What is all this other magic stuff here? Public, static, void. We'll talk about those later. Ooh, string. What is a string in any language? It's a sequence of characters, right? Like hello world, right? In Java, a string is designated with double quotes, just like in C. In Python, you can do the same thing, right? In Python, what else can you do, though? Single quotes, right? You can't do that in Java. That's single characters only for single quotes. But otherwise, you say print, right? That's going to be in both languages. In C, you use printf. In Python, you use print, or maybe you did a formatted string of some sort, right? So already we're seeing familiarities between the two, the programming languages that you're already familiar with and Java already, right? There's your first program. This, if we were grading this, this would get 100%. It's got all the documentation, it compiles, it runs, it does what it's supposed to. Right? We'll pick it up there on Wednesday with more Java.